Welcome, space enthusiasts, to a voyage beyond the charted territories of our familiar cosmos. Today, we embark on a quest to unlock the secrets that lie just beyond the horizon of the observable universe, pushing the very limits of our understanding and igniting our sense of wonder. We stand beneath a night sky teeming with stars, a humbling reminder of our place in this vast and mysterious expanse. Our universe, a tapestry woven with billions of light-years of stars and galaxies, is vast beyond human comprehension. Yet, for all its grandeur, it's just a fraction of the entire picture. Imagine a giant bubble that's roughly the size of our observable universe, limited by the distance light has had time to travel since the Big Bang, the epic cosmic boom that ignited everything. This 92 billion light-year bubble represents everything we can perceive with our current technology. Light, the fastest messenger in the universe, takes an incredible journey to reach us. So, anything beyond this boundary remains unseen, shrouded in the darkness of unimaginable distances. But is there a definitive edge, a cosmic wall marking the end? Physics suggests otherwise. A faint echo from the early universe provides valuable clues about its size and origin. This echo is the cosmic microwave background radiation, CMB, a uniform bath of radio waves permeating all of space. It's a fossilized snapshot of the universe just 380,000 years after the Big Bang, offering a glimpse into its infancy. By meticulously studying the CMB's temperature fluctuations, scientists can estimate the size and geometry of the observable universe. These fluctuations hint at a universe that is flat and potentially infinite, although the jury is still out on this definitive answer. Beyond the observable universe lies the unobservable universe, a realm veiled in darkness. Light from these distant regions simply hasn't reached us yet, and may never do so. Yet, theoretical physics offers tantalizing glimpses into this unseen realm. One captivating hypothesis is the multiverse, a mind-bending concept proposing the existence of numerous universes, each with its own unique laws of physics. According to this theory, our universe is just one bubble in a vast cosmic ocean of countless others, each potentially harboring its own stories and wonders. Dr. Michio Kaku, theoretical physicist. The multiverse concept, rooted in the principles of quantum mechanics and cosmology, presents a fascinating possibility. It could explain the fine-tuning of physical constants in our universe, where everything seems perfectly balanced for life to exist. The multiverse could also hold the answer to the existence of realities beyond our own, each governed by different laws. The concept of a multiverse raises a multitude of questions. Could these universes be identical or vastly different? Do they interact with each other in any way? Is there a master set of laws governing the entire multiverse? Or does each universe operate independently? While the idea remains speculative, it pushes the boundaries of our imagination and compels us to consider the vastness of existence beyond our own cosmic bubble. Could these unseen universes hold answers to some of the greatest mysteries of our own, like the origin of dark matter or dark energy? Even within the observable universe, a hidden structure emerges, the cosmic web. This intricate network of galaxies, connected by invisible threads of dark matter, shapes the distribution of matter on a grand scale. Galaxies cluster along these filaments, forming vast walls and voids, painting a breathtaking picture of large-scale cosmic organization. But what lies beyond this cosmic web? Could there be unseen structures, vast voids filled with unknown phenomena, or even other universes existing in parallel to our own? Dr. Lisa Randall, cosmologist. The cosmic web reveals the large-scale structure of the universe, offering insights into the forces shaping its evolution. As we push observational boundaries with telescopes like the James Webb, the possibility of a vast, interconnected multiverse emerges, a concept that stretches our imagination and challenges scientific inquiry. It forces us to question whether our universe is truly unique or just one player in a much grander cosmic game. Imagine traveling aboard a spaceship, accelerating indefinitely towards the farthest reaches. How long would it take to reach the edge? Would anything be there? Could you even return? These existential questions highlight the limitations of current space travel. Even at the speed of light, a concept with its own theoretical limitations imposed by Einstein's theory of relativity, vast swathes of the universe remain forever out of reach. Recent discoveries by the James Webb Space Telescope, revealing galaxies formed just 600 million years after the Big Bang, challenge existing models and suggest a potentially older universe. This has profound implications for our understanding of the cosmos, forcing us to rewrite the timeline of cosmic evolution. Physicist David Kipping has explored the hypothetical scenario of a spaceship accelerating indefinitely. However, the laws of physics, particularly special relativity, impose limitations. Reaching the speed of light becomes impossible, and the ever-expanding universe itself could prevent a return from a certain point. Meanwhile, the observable universe expands outward at a staggering rate. While the visible boundary is constantly growing, countless galaxies beyond this threshold will remain invisible and unreachable. The light they emit will forever be out of reach, a cosmic farewell fading into darkness. Billions of stars vanish from our observable window every second. This stark reality reveals that only a tiny fraction of the universe is truly accessible. The vast majority of galaxies will forever exist beyond our reach, unseen and unexplored. Over 96.7% of observed galaxies have already vanished, and their light will never reach us. Out of 4.7 trillion galaxies, 4.634 trillion are beyond our reach. Currently, only about 66 billion galaxies are within reach. Each galaxy contains around 400 billion stars. Roughly 60,000 stars disappear from our view every second, resulting in millions already vanished. We will continue to see their past light, but new light they generate will never reach us. We are no longer connected to them, and any information becomes unattainable. Galaxies will eventually sink into darkness and solitude as stars burn out and black holes evaporate. The universe will be left with empty space and dark energy, leading to eternal exponential expansion. Events in one part of the universe will not affect others. The universe's boundaries are questioned due to assumptions about its flatness. The javelin argument proposed by Architas suggests that an infinite universe must have edges. Recent work suggests the universe could be closed, but warped on large scales, with 18 possible forms being discovered. As we peer into the distant future, a question looms large. What is the ultimate destiny of our cosmos? Will the relentless expansion driven by dark energy lead to a frigid wasteland, the Big Freeze? Or are there other forces at play, shaping an outcome beyond our current understanding? Dark energy, a mysterious force permeating the fabric of space, continues to baffle scientists. It counteracts gravity, driving the accelerated expansion of the universe. Understanding its nature is crucial to predicting the ultimate fate of our cosmos. Dr. Brian Greene, theoretical physicist. Dark energy is one of the greatest puzzles in modern physics. Whether it arises from the quantum realm or represents a new form of energy entirely, its discovery challenges our understanding of the universe's evolution. Could it be a remnant of the Big Bang itself, or something more? While the definitive answer remains a cosmic mystery, several captivating theories explore the possibilities. The Big Freeze. If dark energy continues to dominate, the universe will continue to expand, galaxies will drift further apart, and eventually, all stars will burn out. The universe will descend into an unimaginable coldness, devoid of light and activity. The Big Rip. A more dramatic scenario suggests dark energy could become so powerful that it begins to tear apart the very fabric of space-time, ripping apart galaxies, stars, and even atoms themselves. The Big Crunch. In this less likely scenario, gravity eventually overcomes dark energy, causing the universe to begin contracting. Galaxies would collide, stars would merge, and everything would eventually collapse back into a singularity, potentially leading to another Big Bang. Every new discovery Every groundbreaking theory pushes the boundaries of human knowledge. Telescopes like the James Webb Space Telescope peer further back in time, revealing the universe's infancy and offering clues to its evolution. Missions like the New Horizons probe venture deeper into space, gathering data and painting a more complete picture of our cosmic neighborhood. Space exploration thrives on international collaboration. Nations around the world come together, sharing resources and expertise to unlock the secrets of the cosmos. The International Space Station serves as a beacon of this collaboration, a testament to the unifying power of scientific inquiry. The future of space exploration promises exciting possibilities. Missions like Artemis aim to return humans to the moon, paving the way for a permanent lunar base. Powerful new telescopes like the 30-meter telescope will peer further into the cosmos, revealing never-before-seen details about distant galaxies. Our exploration of the cosmos is a voyage of discovery, fueled by an insatiable curiosity about the unknown. Every observation, every mission, every scientific advancement deepens our appreciation for the universe's grandeur and complexity. As we conclude our odyssey beyond the known universe, let the spirit of wonder continue to guide us. For in seeking answers to these cosmic mysteries, we embark on a journey of self-discovery, reminding ourselves of our place in this vast and awe-inspiring universe. The possibilities are endless, and the future of exploration holds untold secrets waiting to be unveiled. Thank you for joining us on this exploration of the cosmos. If you've enjoyed unraveling these mysteries, be sure to like, share, and subscribe for more cosmic adventures. Until next time, may the universe ignite your curiosity and inspire you to seek wonder in all things. Stay curious and keep exploring.